In this section, we're going to build a better structure for our REST API, the Express backend project we have here. And we're going to also enable a way to store the user's password securely using something like bcrypt. So that's what we're going to look at in this section, some refactoring, get a really good structure for our REST API, and saving passwords of the users. The first thing I'm going to do is I'm going to make a folder here that's called config. So that's just new folder. Let's call it config. And then inside that, I will make a new file and I will call it MongoDB. So in here, I will put my various passwords, credentials to APIs and so on. So I have them in one place in case I need to change them. So I'm going to cut the MongoDB connection string we have here and paste it inside the MongoDB file inside the config folder. And then we simply say module.exports MongoDB connection string. And then we can import it over here. So we say MongoDB connection string, require, and we pass in the config folder and the MongoDB file. And then we can simply use this one, which we already have defined actually. So now it should be working as usual. And now that we changed the connection string, or rather put it somewhere else in the config file, let's see if our backend is still working. So let's go inside the Express backend folder and run nodemon index.js. And we can see it says connected to MongoDB and server is listening. So everything is still working. Okay, so now we just refactored our MongoDB connection string to a separate file. Now we also need to do something similar with our routes for the users. Now in this small app or REST API we have right here, it's not that visible or important that we try and do this refactor, but imagine that you have 100 different routes. Then you would have a huge file just for just one file for all of these different routes connecting to the database, having lots of different models. It's going to be really messy to look around and navigate inside one big file. So what people do instead is that we refactor this into separate routes and controllers. So let's first make a folder we call routes. And in here, let's make a file we call users. And now we're going to just cut these two endpoints here for the get and the post. Cut that and paste it into the users file inside the routes folder. Then we also need to cut the user model because now we're not using the user model inside index.js anymore. We're going to use it in here. And now we need to import the user's route in the index.js, and then we can start just having the routes in here. So now everything specifically for the user's endpoint is inside this user's route to be accessed from. And we also need to go up one directory in this one where we import the user, because now we are inside the routes folder before we were inside the index folder. So now that we have this, we need to use it. Actually, we need to use a router first. So we first we import Express, where we say simply require Express, like in our index.js file. And then we need to make a router for Express, which is going to handle all these routes that we define. So we say express.router. Express.router with the parentheses around. And then simply instead of having the app where we define the routes, we use the router instead. So I'm just going to paste that in for the app instead. And then once we've done all that, we can export the routes or the router. So we say module exports router. And then now we can start using it inside of our index.js file. we simply say apt use, and then we import the user router. So we say const user router require, then we pass in the routes and users. So that's our user routes. And then we simply use it in here, just like that. So now we are using all the routes we defined in here, but we just have this simple use function we call instead of having all the functionality inside here. Now let's see if it still works inside of Postman. Let's see if I can post a file. I can still post and create a user, and I can also still fetch a user. So all of our routes are working just as normal, or just as they did before. There's also another cool feature about this is that we can say, instead of repeating this users for every route that we make, we can simply define it already in here in the index.js. So we say users and pass in user router. And then we can remove these users, this repetitive users for every endpoint or every method that we make. And now it's simply going to work just as before, but we only write users one place instead. So let's see how it looks if it's still working. So I can still fetch a user and I can still create a new user. Now in the next section, let's look at how we can create controllers in the Express framework. So now we just refactored all of our routes for the users into a routes folder and the users file instead of having it inside the index.js file. We're now going to do one more refactor where we're actually going to refactor all of these methods or the logic into separate controllers. So this means that it's easier for us when there's a lot of routes to easily see all the routes in the routes file and then go to the specific controller that handles the logic itself. It also means that it's just more modular. The whole point about this refactor again into controllers is to make the code more modular and separate the routes from the logic. So let's first make a controllers folder. And in here, let's make a users file, again, just like with the routes. And then we're going to take this logic itself and we're going to cut it and paste it inside this controller. And then we're going to say simply exports dot, and then we call the method something like fetch or get user. And then we simply have a method that we can import or use from other files. So then we can say const user controller require, and then we go to the folder. So we go up one folder, then into controllers, and then into users. And then we can put a comma and use user controller dot get user. So now instead of having this logic inside of the routes file, we refactored it out into a separate controller. So now all this logic is in here. And now let's do the same thing for where we create a user. So we cut this and paste it inside of the user controller. And then we say simply exports dot create user and save it like that. And now we can use the user controller create user. And then just like before, we need to import the user model inside of the controller instead, because now we're no longer using it inside of the routes file. So we cut that and paste it inside of the controllers file. Just like that. And that should be it. Now let's test if our routes are still working as before, and we should be good to go. So let's see if I can still fetch a user. I can still fetch a user, and I can still create a new user. So that is it. That's how we have a really good base structure for when we need to create new controllers, create new routes, and expand further on our project, rather than having all of this logic and routes and so on inside of just one file. Now, next section, we're going to look at how we save the user's password securely and use something like bcrypt to password hash. Now let's say we want to add a password and an email to our user model. So we could just go and say email is a type of string and it's required. And we also have a password, so people can log in, of course. And we have a type of string and it's required. So now let's see if we can create a user model just like that by adding these extra body keys or parameters. So we say password and we say my super secret password. And then we have an email and we add an email. And then we try and post or create the user. So now I get the object back here with my password and my email. Now let's see how that looks inside MLab. It should look the same. So inside MLab here, we can also see the object here. Now, this is not good because we are saving the password as a plain text password. And this is a big no-no. Sometimes you have scandals coming out about companies who do this mistake, like Sony did, I believe, also saving credit cards and so on. We need to encrypt or hash this password so that there's just a long gibberish line of string. And we're just going to hash whatever people pass back and compare that if it's the same. The reason we do that is just in case someone gets access to our database, like hackers or so on, they still can't see what passwords our users have been using. So that is the reason why we hash these passwords, is so that we never no one is ever able to see what passwords people are using, but we can still compare what people send to us and see if it's the same. So let's try and do some password hashing so we have a more secure database. In order to do that, we need to import the module that is called bcrypt, which has a password hashing function for you. So make sure to go into the Express backend folder and then use yarn add bcrypt or npmi if you prefer to use npmi. But the package is called bcrypt. And once we imported that, we go inside of our controller. And then we need to import the bcrypt by using require. And then we need to hash the password here. So the way to do that is, well, we need to first get all the plain text password and so on. So we go and say, well, we get the first name, last name, email, and password from this rec body object. And now we need to encrypt the password or hash the password. So we say const hashed password. And here we say await bcrypt hash. And in here we pass in the plain text string that we want to encrypt. And here you pass in how many rounds you want it to be encrypted. And in general, the people say that 12 rounds is considered secure. So we just use that by default. And so here we have the hash password. And now we can save it inside of our user model. So here we pass in the first name, last name, email, and then we have the password, which we're going to use the hashed password instead. So remember to use the hashed password instead of just password from this body parameter. And now let's see if we are saving this password as hashed password if we try and create a new user. So now I still have this my super secret password, but let's try and see what happens when I try to do a post again. So now we get this long gibberish string, which is a hashed password. And if we look inside of the imlab, we should also see this hashed password again. So here we have the previous one with the plain text password, and now we have the hashed one here. So now, even though someone gains access to the database, they still can't figure out what exactly your password is unless they try, of course, every kind of password in the world and see if they can get a match with this one. So that is how you encrypt passwords and store them securely in the database. In the next section, let's try and do a login function where we try and log in a user and compare the password they provide with a hashed password. Now we build the login function so we can test out if this hashing of our passwords is actually working, if we can get a successful login even though we hash the password in the database. So first, let's create a login function inside the controller, login user, I will call it, with the rec and res objects. And well, let's first simply say you logged in without doing any checks, just to see if we can get the route working. And so now we created it inside the controller. Now we also need to create a route inside the routes file. So we say router post, and then we say /login, and then pass in user controller and say login user. So now let's see if it works inside of Postman. So we go and create a new tab here and say http localhost /users/login, because remember that we had this prefix of users already that we defined inside the index.js file. So when we have /login here, it means that users is already prefixed on it. So now we have this login here. Let's see if it works when we use the HTTP method post, and it simply says you logged in. So now let's build a little more logic for this login function so that we can actually test if our login is working. So we're going to get the email and password from the body parameters. So we say rec body get the email and password. And then we need to check if there's already a user existing with the current email inside of our database. So we say const user find one, and then we pass in any sort of like a where clause in SQL, if you know SQL, or some kind of condition to find this user. We simply say that the email we pass in. And we also need to use async await. So we use async up here. And then we say await. And now if there is a user, then we can start doing some sort of comparison of the password that's in the database versus the password that we now are going to hash. So here we have the hashed password. So let's have the hashed password here, where we say await bcrypt, and then we use the compare function. And in here we pass in the string that we get from the login session, which is the plain text password. and then we compare it to the encrypted password from the user database. So we just say user.password. And well, now we have actually not the hash password, we have the result of this comparison. I will call it is password correct, and then we can check, well, if the password is correct, then the user is logged in. So if password is correct, then we return we can say you are logged in. And well, if there's no user, then we need to return that the user doesn't exist. So if this case where the user is not existing is false, we need to return that, well, the user with this email or this email doesn't exist. This email does not exist. And again, if the password is incorrect, then we send password does not match email. And let's also just pass in the email for good measure. Just like that. Now let's test out if it works correctly. Let's first just go through what the code is doing. So first we go and look for a user. We find one using MongoDB with this specific email that we pass in through this route. And if this user is existing, then we check if this password that we supplied up here from the request body is the same as the password that we have stored inside the database, which is the hash password, which is why we're using bcrypt compare. And then if that password is correct, this is either a Boolean with a true or false. If this is true, if the password is correct, you are logged in. But if it's not true, if it's false, then we simply go down here and say the password does not match the email. And again, if the user doesn't exist also at all, the one we're trying to find with the email, we return this email does not exist. So let's see how that works. So I go in here, and then we need to go inside with the body tab and use form URL encoded. And we pass in an email. So I'm going to use the email from the post request we used before here with my email here and paste that in. Then I'm going to take my super secret password and paste that in as well inside the password value. Now let's see what it says. It says you are logged in. But if I change this one with an extra one in the end, so there's no email that exists with this name, then it will say this email does not exist. And if I try to put now I just get a logged in again because I remove it. If I try to put a wrong password in, then it says the password does not match the email. So everything is working just like it should be. So that is how it works. It simply hashes the password, and then it checks if this hash is the same as the hash we have inside of the database. Now there is one more thing we need to fix to this code. If you try and test it out by saying login, then you will see an error in the console log about that there's cannot set headers after they are sent to the client. The reason why is because you're running this code in async. So let's see, even if the user exists and the password is correct, then we send the you are logged in, which we see here. But because this is running in async, this means the code will keep on running further in the function. So it runs through here, and then maybe it also goes through this one and even to this one, because it's running an async. So it's just sending the response here, and then the code keeps going on. That's good for some things. Maybe you don't want the REST consumer to wait for a long time while you do things in the background. But in this case, we don't want to have lots of garbage console logs in our console log. So we want to just return one response, and that should be it. In order to do that, we need to use the return statement instead of just saying REST send. So return send. So return REST send, and that means that now the code is going to simply exit at any of these points. And we should not see this error here about an HTTP header trying to be set because we already sent a response. So let's see now if we try the same sort of request again, and we don't see any sort of console log error now. So remember that if you have multiple exits at your response and several cases you can have, then you should always try and use return so you don't have the code execution that keeps going on. Now there is one more thing that we need to cover or fix in this code so far, and that is that we can actually create multiple users with the same email right now. So if we have two users with this email, well, it's not going to end up well for us because we just want to find one user. So we need to have something similar to this where we say find one and check if there's a user already existing for this create user function. That's what we're going to do in the next section. So here you can see we can actually create multiple users with the same email. So now I just created two users with the same email, which is not good because we use that sort of as an identifier in our database. In order to disable this functionality, it's quite simple actually. We just need to say if there's any users, find one user with this email. And if there's any users with that email, we simply return a response saying that the user already exists. So we say status. The status in REST, and there's kind of difficult. It's not really a convention, but from what I read so far, 409 is a good error response in case the resource already exists when you're trying to create a new resource. But you could also just return error 500 or 44. It doesn't really matter that much. We're going to send back the response saying an account with the email and pass in the email already exists. Now you could of course also just return an error saying error logging in. If you don't want to disclose that this email exists, you could also choose to do that. But I just prefer to keep it simple and do it this way. And remember to use the return statement so we don't keep on going through in this code. That's important that you do that. Now let's try and see if I can still make a new account. No. So now it says an account with the email already exists. So I'm just going to go ahead and delete both of these email ones I made because I can't remember which one has what password. So I'm just going to delete both of these and create one later for testing. Okay, so that is it. Now we also need to look at something with tokens, because right now when we are logged in, we just return a response saying you are logged in. But we also need to return something that the user can actually use so that you, for example, can request a ride. The way you usually do that is by using something called tokens. in this case, JSON Web Tokens. So we're going to return a token that we generate, and then the REST consumer or the user is going to pass this token back every time that they use the REST API to sort of authenticate themselves and tell the API that we actually are logged in.